Welcome to Java lecture number 7, where we're going to talk about methods and stuff. And then we're going to hit the wrong button in Discord a whole bunch of times. So, let's talk method signatures and static. We're going to start this time with a chunk of code you may have seen before, because I took this code out of the notes file for lecture number 4. Because I wanted to just have a block of code that, like a pre-written block of code that I could just kind of work with, and demonstrate a few things with it, and also add in a few things based on what I wanted to talk about today. So, first off, let's talk method signatures. So, this line here is a method declaration. Actually, before we even talk about that, do I actually have an audience here that's alive, or are we in the exact same situation we had last week where literally everyone is dead? I think last week our record was having 9 people dead at the same time. So let's actually carry on. So, method signatures in Java follow a pattern. And that pattern is access modifier, whether or not it's static, return type, name, parameter list, and then the actual code. So, for this one, public access modifier, void return type, method name print black white, it takes in a single string as a parameter. And so, what is this access modifier? That was something that came up at the beginning of lecture 4, with the common access modifiers you see being either public, meaning that it can be that this method can be called upon from anywhere else in the program. Private, this method can only be called upon from within the class you're currently in. Protected, the method can only be called upon from the class that you're currently in, or any class which extends it. And sort of the invisible default one, which I would like to call package protected, which is it can be called from any other class within the same package, but not outside the current package. Return types. So the return type on a method is what sort of data the method gives back at the end. So down here for public double get black ink, if the method has a return type that is not void, then the method must end with a return statement that has some actual value attached to it. You are allowed to have multiple return statements in one method, but if you have a return type that is not void, you must return some value at some point. And the type of data that is returned by the return statement must be the type of data that is defined by the return type on the method signature. Method's name is just kind of the method's name. We do like to do camel case on method names, the same as we like to do camel case on variable names. And there's kind of a reason for that, because when you call upon a method in the middle of a line of code, the value that's returned by that method gets dropped into that spot in the code. So same place how when you call upon a variable in a line of code, the value that is stored in the variable gets dropped in there. And then the parameter list. So methods can take in data in order to be able to run, and so you need to give them a list of what pieces of data they're going to take in, and what pieces of data they're going to take in, and what type they all are. What defines a unique method signature is the combination of the access modifiers, the return type, the name, and the exact order of the parameters and their types. The names of the parameters don't actually matter for these purposes, but the type order matters. And when I say unique method signature, Java supports something called method overloading, where you're allowed to have multiple methods that have the exact same name. So long as they all have signatures that don't quite match. Where the thing that can make them not match is either the access modifiers, or the method name, or the return, or the order of the parameters and the set of parameters. So these 4 print black whites would all be distinct methods and would all be legal to have all in the same program all at the same time, because all of them have different parameter lists. However, like I mentioned with the names, actually never mind, these would not be legal, because you can't have multiple variables with the exact same name. So let me try that again. So, but int. Okay, so first one, second one, third one, fourth one, all of these are legal, and all of them can exist all at the same time, because they all, even though they all have the same name, they all have different parameter lists. But this one would not be legal, because even though the names on the parameters are different, the types are the same as the previous one. So, method signatures themselves is not a topic that has an enormous amount to say about it. Especially because we've already talked about like what a method is and how a method works. I just wanted to have a moment to sit down and talk about all of those individual pieces. And to that end, let's go on to the next piece, that nice little keyword called static. At 11:14. I'm keeping timestamps this time. So, it's probably been brought up at some point that the Java language likes being object-oriented, that Java is an object-oriented language, and that Java likes dealing with objects as much as possible. And what you saw from me during last week's lecture was a whole lot of stuff that wasn't really object-oriented, because I didn't need it to be. So, the static keyword is the big golden keyword that tells the Java compiler, alright, we're not dealing with objects for right now. What we're dealing with here is just straight up code that will just exist on its own and run on its own, and you don't need to think about creating objects or object states or anything like that in order to make this code run. You can still reference objects inside it, and you have to at some point, but static can be applied as a modifier onto either a variable or a method. And when a variable or method is declared as static, it indicates that there is only one of this variable that exists across the entire program. This is distinct from what we've seen with the non-static fields that we saw when we were defining what a printer is, where the non-static fields exist an independent copy of each of those fields for every individual instance of the object. So I have here private static int next sn. There's going to be only one next sn, which is shared across every single printer in the entire program, and that next sn is it exists at the level of the printer class, which is a little bit above the level of an individual printer object. You can still work with static variables inside non-static methods. However, you cannot actually, I'll get to that in a minute. You can still work with static variables inside non-static methods. And to that end, I'm going to be adding a second field, an extra new field here. Int. So everything that you've ever seen built has a serial number stamped onto the side of it, and that serial number often reflects how many of that individual thing is built, and so the serial number is which numbered thing this is across all time. So let's say every time we create a new printer, the new printer will have a serial number equal to whatever the next serial number printer would be. But then because you've now used that serial number, you need to bump the serial number up. No matter how many printers we create, next serial number will continue updating to reflect the new next serial number. But it also won't break this because they're separate variables. So let's hop back up. Let's hop over to main for a minute. Actually, no. Let's be a little bit better than this. Let's not create one printer. Let's make a bunch of printers. Let's make 50 printers. So, we're going to create 50 identical printers, or mostly identical printers, but as I'll get to in a moment, each of these printers will have, all of these printers together will have the same next serial number value, but they will all each have independent serial number values. In order to reference that, I need to go and get myself a pair of get methods for that. Okay, created my two get methods. So now let's use them. Okay, so one of the things that comes up here when we're talking about static methods versus non-static methods, as you would have seen in Lecture 4 and 5, when you're calling upon a non-static method from when you're calling upon a non-static method, you need to call upon it based on an object. Meanwhile, when you're calling upon a static method, you want to call upon it from the class. Because the static method exists at the class level rather than existing as part of an object. It is legal to call upon a static method or a static variable from an object, but it's generally better form and it's generally much clearer if you call upon it from the class rather than calling upon it from an object. Makes it much more obvious to yourself and to other users that, or other programmers that the value or method that you're trying to deal with is static and is not tied to an object. So let's just test this. So create a whole bunch of printers. Let's check the serial numbers on a couple of random ones of them, and then let's check what the next serial number for the next new one would be. All right, where have I gone wrong? Main.java cannot find symbol. Ah, yes, because I didn't call it getSerialNumber, I just called it getSN. Okay, so for these 3 random printers that I chose, they had serial numbers of 8, 9, 22, and then the next new printer that it gets created would have a serial number of 51. Because that original 1 got bumped up 50 times by creating 50 new printers. Because there's only one of that next SN in the entire program. And as a further demonstration of that, so this is the original 4 again. 721 and 18 had serial numbers of 8, 22, and 19. The next printer created would have a serial number 51. Create a new printer. That new printer does have a serial number 51, and the next serial number bumps to 52. So, this is a brief introduction to your brief introduction to how static goes. Now let's look at one more curiosity that I can talk about because of last week's lecture and this week's lecture combined. Look at this line. Public static void main string array args. So this is a line that you've written in every single program because it has to be somewhere in every program. But now we can talk about now we can see what all of those individual little words mean. Public. So the main method has to be public. It has to be accessible from anywhere in the entire program because this is the base starting point of the program. You need to be able to get to it no matter where you are because you need to be able to, run the program. You need to be able to in particular, you need to be able to get this method from some unknown arcane location within the Java runtime environment, which isn't even any code you wrote, it's just what the Java language requires in order to do anything. Static. That main has to exist outside of an object. It has to just exist in the code and be runnable with no outside objects being created. Void. In Java, main does not return anything. Main simply ends. There are other languages in particular, like the C family, where main is often written as an int return type, which allows you to return code numbers as the part of the return. You can still do that in Java, it's just done in a little bit different way. And then string array args. So, when you're calling upon a program from the command line, you can give programs from the command line extra command arguments. If you've ever played around in either the Windows command prompt or a Mac or Linux console or terminal, you will have encountered this extensively. You will have encountered calling upon a program or running a program from command line and giving it potentially a big long list of, stuff in order to make it work. For Java purposes, this is where all that goes. When you call a program from the command line with a whole bunch of extra stuff tacked onto it, it goes into that string array of arguments on main. Alright. So, I'm going to pause for a moment now and ask if I've totally lost everyone. Because I've been seeing a grand total of no traffic in the Java Questions channel so far. Except for that one other person who said he's not dead and then deleted his message. One person says all clear, one person says one person says typing. One person stopped typing. Oh no, I called them out. Crickets. Okay. Well then. If people aren't asking interesting questions the way last week went, I guess this lecture might wind up being a little bit shorter than expected. All right. So, let's move in to the next let's move into the next topic of the day, which I wanted to go and talk about method signatures first, so that I could then move into talking about one of the most useful tools that I've had when dealing with the Java language, and that is the Oracle Java documentation pages. This is a website, and a website containing, honestly, thousands of web pages, where this is a website that was written by the publishers and authors of the Java language to detail all of the features and all of the classes and methods that were built into the language by the original developers. So this is a tool to be able to look up everything that the language knows how to do on its own, so that you can then use those tools yourself in your programs without having to reinvent the wheel every time you want to get something done. In order to do that, we're going to go over to Google, and we're going to look up Java string. And why string? Because it's an easy thing to look up, and it's an obvious thing that we know. So, what we're looking for is this URL, the docs.oracle.com Java SE docs API, and we're probably going to want to use the, if there's options for multiple versions like this, you're probably going to want to look for the Java Se9 one as opposed to the Java Se7 one. Even though I think the Java Se7 one looks better, Se9 is more up to date, and the specifications of the language have changed over time, and so there are features of some of the newer versions of the language that simply weren't there in older versions. And so it's always best to use whatever the newest one is. Technically speaking, we're all running on, Java, like 12 at this point, I think? 13 even, maybe? I don't even know what version Java's on at this point. But the most recent doc pages I've seen usually wind up being Java 9, so that's just kind of what I look at. Okay, so we look at this Oracle 11? Yeah, 11. I mean, I actually haven't paid attention since 8, so what do I know? Java's Java. And as far as I'm concerned, honestly, like, Java 9 was about the point where they jumped the shark and started trying to do for a faster release schedule of more major versions in less time, and also kind of when they started adding weird stuff to the language, like functional programming for some reason. Anyway, moving on. So, we go to this page, the one of these Java Se9 documentation pages, and what we see is an enormous amount of text, and most of it looks like it's written in an alien language. Overview, module, package, use, tree, deprecated index, help. I usually just ignore all of that stuff. And all of this stuff. And I basically just ignore the entire header bar. And look at the actual stuff. So, package. So this module and package. So this tells you where in the language the class you're looking up exists. And when you're doing an import of something, for example, some time ago we talked about the scanner class. Scanner is in java.util. So then in order to have scanner available in our program, in order to be able to get user input from the console, we had to start the program with import java.util.scanner. String is within the Java lang package, and the java.lang package is silently imported into every program, because that's just the core of the Java language. So, module Java base, package Java lang, class string. Up next we have the class hierarchy of what set of classes exist that this class extends off of. So, string extends off of object, string doesn't extend off of anything else. Scanner extends off of object, scanner doesn't extend off of anything else. These aren't very interesting examples of that, but there's more interesting examples of it that exist. Interfaces. I don't think we've actually talked very much about interfaces, but when interfaces do come up in conversation, if any one of these classes you're looking up has interfaces that it implements, you will see those interfaces here. The interesting one that I'll probably mention later is the comparable string interface. Moving down from here, we have so this chunk of text here, this is the formal class declaration if you were to see it in code. Public final class string extends object implements serializable comparable string char sequence. This is just a formal way of saying all of the stuff that was up here. And then this big block of text, which is actually written in English, is an explanation written by the Java developers of what this class is, what an object of this class represents, why this class exists, and some simple details about how to work with it. Character strings, immutable constants, little bits of playing around to an amusement over the fact that strings have a lot of crossover with arrays. Simple things, a couple of simple things you can do with strings. Characters from the sequence. That one weird thing that Java allows for a plus between strings. Unless otherwise noted, passing a null exception to passing a null into a constructor or method will cause a null pointer exception. That is one of the reasons why it's nice to read through this summary, because that is a very interesting and significant thing to note if you are planning on working with strings in a context where nulls could appear. Some memory stuff, Unicode, character points, and then some of these other things are language specific or implementation specific or regional specific. For example, if you're using if your computer works in a language that isn't English and uses a much more interesting character set, like if you happen to be working in Russian and thus you're using a Cyrillic character set, you might need to look around a little bit and make sure and poke at your strings in order to make sure that everything's working correctly. Implementation note, string concatenation is up to left to the implementation notes. These shouldn't really be important to you most of the time, because most of the time we're just dealing with the original Java-C compiler. The Java language was technically written as a specification so that other organizations could write their own Java compilers at will if they wanted to. Almost nobody has actually ever done that, though, so most of the time, like, Java just winds up being compiled via the Oracle Java-C compiler. All right, let's get into the stuff that I really wanted to talk about, and why it can be confusing to try to read through the documentation pages. Field summary, constructor summary, and method summary. This is the real meat of the Java documentation classes most of the time. Field summary is at this point on, this is listing all of the things that exist within the class. At least all of the publicly visible things. This won't usually tell you about anything that's private and exists in the class, because as it's a private variable or a private method, you don't need to think about it ever, because you can't get to it because you're not inside the class. You only can deal with the public stuff. So, fields. So, the string class has a single static field of type comparator string named case insensitive order. So, what that means is that if you were in a place where you needed to compare two strings ignoring the case, and you didn't want to go through the normal method way of doing it, this would be a way of getting to the raw comparator object that would let you do that. That might sound like a bunch of alien words, because it is. But what's more important is that the field summary lists what field variables exist in the class that you can get to and either modify or access if you need to. Constructor Summary is much more significant for us, because Constructor Summary, this is all the different ways that you can create an object of that class. You have a constructor which takes in no arguments, and you have the no argument constructor creates an empty character sequence string. You have a constructor that takes in an array of bytes. You have a constructor that takes in an array of bytes and an integer. However, this one has the big word deprecated on it, which anything that has the big word deprecated on it, deprecated indicates that the language developers have said we don't want to deal with this method anymore. If you're trying to use this method, you need to be aware and be cautious that this method will cease to exist at some point, and so you should probably use a different method to do this job. Methods are usually deprecated because they were created in ways that are no longer practical, or have some other inherent flaws to their design that were not obvious when the methods were created. And as these languages evolve over time, you wind up with some pieces of them that just aren't useful or relevant anymore. So, byte array, int high byte array, offset length, another deprecated one, other variations of offset and length, char set name. So this is one of the new ones that came up, the idea of string char set name. This is when these two constructors that were deprecated, both of them have a note. Preferred way to do this is via the string constructors that take a char set or char set name, or use the default char set. So char set in strings is the base set of characters that the language that you're talking with is working in. I mentioned Cyrillic or Russian as an example earlier, that the Russian Cyrillic alphabet does not use the what would you call it? The English language alphabet? Whatever alphabet I'm using that you can see on my screen right here. I don't know a more formal name for it. I am unsophisticated, uneducated American. Everything is American to me, so what do I know? But it's like if you were dealing with, say, a program if you were dealing with strings that were written in Cyrillic, you would need to play around with char set in order to make it so the strings would actually work correctly. Bytes, char set name, bytes, char set. Character array value. So, next way to create a string is by just straight up giving it an array of characters. Or giving it an array of characters and tell it to only do a little bit of it. And then, at the end, we have the ability to create strings out of copies of other strings, or the contents of a string buffer or a string builder. So, look at all these different ways you have of creating a string. All of these different ways. Fortunately, we don't need to deal with most of them. Most of them, a lot of them, they exist so you can do lower level things and do things where you're interacting with more raw data. But fortunately, we don't have to deal with most of these things. You still want to be aware that they exist in the class, though, because everything that exists in the class is a tool that you can use for something. Method summary. So, this is every single method that exists within the Java string class. There's a lot of them. They can then be broken down into the static methods, the non-static methods, concrete methods which are actually implemented. If this class was an abstract class, or if this class was... Yes, if this class was an abstract class, there would be another category here, the abstract methods. However, this class is not abstract, so I can't show you that. And the deprecated methods, which are the ones that don't... which... It says here, deprecated. This method does not properly do the thing it's supposed to do. Well, that's probably why it's deprecated, because it doesn't work right. Why does it not work right? Because of... It was written in the original version of Java, and it was written assuming that everyone was going to be using the English language character set, and it didn't know how to deal, and the Java developers didn't deal with, people that weren't working in English. Presumably because they were just dealing with version 1 and trying to get the thing to work. Anyway, though, deprecated methods, like I said, don't want to really use them. So, static methods. All of these methods are static methods that exist within the string class. So you can call upon... Oh, here's a good one. String.format. String.format, where you give it a string and then you give it a bunch of stuff to shove into it. Or the instance method. So you can, if you have a string object you've created, you can call that string object .charat. Give it an index, and you can get that single character from it. One of the big things about this web page is that all of these things are links. If I go to one of those links, it jumps to further down the page in order to show you a formal definition of that method. So for string.format, we have the method signature and the method declaration, public static string format. It takes in another string format, another string, and it takes in object ... So the ... specifier on a method signature states that you can give this method a variable number of that type of argument. So you can give, so when you're calling string.format, you need to give it a string in order to, and you need to give it a string to work with, but then you can give it any number of additional things after the initial string. And because what it's looking for is an object, everything in the Java language, except for the primitive data types, is implicitly an object in addition to whatever it else is. So if you have anything that's requesting, if you have any method that's requesting an object as an argument, that object could be literally anything in the language. Any type of data. And presumably, the method will know how to handle it. So what does string format do? Returns a formatted string using the specified format string and arguments. What does that mean? Unfortunately, the language, the Java documentation pages here might not be enough to know what that sentence means. Because these documentation pages were written by Java internal developers for use by Java developers, there are some assumptions that the documentation writers make about how much you know about the language, or how much the reader knows about the language. And in this case, one of those assumptions is that the reader knows what it means to, what a format string means. Fortunately, though, parameters format, a format string. And, if we look down at the bottom, we see that's also another link to another page. What's in this? Format string syntax. So, even though I said that there are some assumptions that you know what a format string is, It then also has a link there, hidden in there, to tell you how to make a format string. And then the second argument list, the argument list of args. You'd need to read the formats, like the format string specifications, in order to know why string.format takes in an object list, or how to work with that object list. But once again, that's within the format string documentation. Returns a format, so parameters, return value, a formatted string, throws. So if this method can throw any exceptions, the documentation page will also explain why, what those exceptions are and why those exceptions would get thrown. Sense states what version of the language this method was created in. See also if there's any other classes in the Java language that have some function that are that is similar or relevant to this. Let's go back up to the top of the page and let's look for another method. String.format. I mentioned the idea of method overloading. There's two different formats. There's the base one, which just takes in a string and a list of objects. But then there's another one, which takes in a localization as well. So, questions on my ramblings of a madman? Obvious things that I'm missing. What object ... means in parameters? Okay. Back over to the code. F5 the code page. Okay, so in that line of what object ... means in parameters, there's two things to unpack there. One of them is what it means when it says object, and the other one is what it says when it means when it says the ... So everything in Java is an object. I was about to say every object in Java is an object, which sounds like a painfully obvious thing to say, but given that we've talked about creating objects, but haven't so much we talked about creating objects, but the term object in this case is very specific because it references the Java object type, the Java object class, which every class has object as a superclass. All objects, including arrays, implement all the methods of the object class. So object, formally speaking, object has a set of methods that every single thing in the entire Java language implements. Informally, everything is an object, and so if you need a situation where you have absolutely no idea what type of data you're going to be taking in, you just know there's going to be some type of data there, and you just need to hold on to it or do something with it, then you can say object as the type. The dot 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 is another bit of a mess. So the dot 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 is a concept which I believe is known as variadic function arguments. The idea that when we've talked about method arguments before, we're used to seeing very fixed, obvious argument lists. So that we have here that like this public printer constructor takes in a double, it takes in an int. What if you wanted to write out a function that could take in an unknown number of things? Let's say, this is not exactly what I wanted to talk about today, but because questions brought it up, let's talk about this because this is interesting, and this is something that is a useful and powerful tool of some programming languages, and it's not a tool that every programming language has. So, static int sum, int dot 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 num. So, let's say we want a method that will get you the sum of a list of numbers, where you don't know how many numbers are going to be in that list, you just know there's going to be there's going to be a bunch of numbers that get passed into it. So, when you have one of these variadic argument functions, inside the function, this gets treated like an array. But it doesn't have to be called like an array. One sec, I'm just going to fill out this method, int I equals 0. So let's look at the different ways that you can call this function, or this method. As far as Java is concerned, they're called methods. As far as other languages are concerned, they're called functions. Easy to get the terms crossed. They basically mean the same thing anyway. Okay, so there's two different ways you can call upon this method. The first option is by giving it a list of numbers, or a list of values. Because of the dot dot dot, you can just have any number of arguments passed into this method so long as they all match that type. And let's just do a print line of it. So you can either call upon one of these functions or one of these methods with a list of round numbers, or with just an actual array. How about I not be an idiot when I'm writing my sum method, though? How about I actually do it, correctly, and not try to add an array to a number? Okay. And I'm pausing and not talking because I'm looking over at the Java questions chat and expecting someone to say something over there. Today, as far as text chatter and Java questions goes, today has been really quiet, and it's actually throwing me off a little bit compared to how much chatter we had last week there. It's Thursday. Does that mean that everyone is 20% more dead than if it was Wednesday? Hmm. Probably. Yeah, dot 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 is it is an interesting thing, and it's a really nice feature that not every language has. I actually encountered it back in the days of back when I was doing a whole bunch of wiki editing, because the standard MediaWiki template code does not allow for dot dot dot, but Lua as a language does, and that came in very useful for us at some point when in the back-end wiki stuff. Well, not back-end wiki stuff, but the behind-the-scenes wiki stuff for making templates work. As far as what sort of languages can do the dot dot dot, the variadic function arguments, Java obviously can do it. The C family can do it, and basically anything that has any language that has a string format type function in it has to be able to do it, because string format doesn't work without the ability to do variadic function arguments. It just doesn't work very well. Okay, we're currently at 19:05, so lecture's been going for 1 hour now, and much as what happened last week at around 19:05, I'm running out of things that I had scheduled to talk about. So this this lecture might wind up being a bit shorter than the original schedule if I just have nothing else to say on what I wanted to talk about. Or if anyone has interesting questions, then we can talk about interesting questions for 20 or 30 minutes. Like, so far I'm seeing a fair bit of Eat Cell talking in Java questions, and not a lot of other people talking in Java questions. So I know that Eat Cell's alive at least, but how are the rest of y'all holding up? Bup and Rohan. Comparator and comparable. Okay. And so, process of declaring package to class to method, and comparator comparable. Okay. Declaring packages to classes to methods. I'm not sure what you mean by that question. So, for this question, can you give me a lowdown of the process of declaring packages to classes to methods? What does that question mean? Because I'm not sure how to answer that immediately. And well, you're figuring out how to you're figuring out how to explain what you mean by that question so I can answer it. Let's talk comparator and comparable. So, comparable is so the idea of comparator, the idea of comparable is how do you sort things that aren't numbers? How do you take two things that aren't numbers and say that one of them is greater than or less than the other? And that's what comparable's for. So, there exists comparable as... Okay! As I open up the comparable interface comparable T, so interface comparable T. First off, you'll notice there's this weird thing of the T in triangle brackets here. So comparable is an interface that was written to work off of what's called generics. And generics are a somewhat confusing and slightly awkward feature wherein you can create a class, and that class can reference objects of another class, but when you're writing the code, you don't know what type of objects you're going to be referencing. You trust that by the time that someone else uses this thing and actually tries to use a comparable thing, they will give a type to fill in that generic type parameter. Didn't expect to be talking about generics today, and because generics are a topic and are 2.5 topics themselves. But because you mentioned comparable, I have to at least mention what generics are. So this interface comparable T, type parameters because it has a type on it, known subinterfaces, all of the other interfaces that extend off of comparable, and then the giant wall of all of the classes within the Java language that implement comparable. We'll just scroll past all that. Interface comparable. Interface imposes ordering of objects. Lists and arrays of objects can be sorted automatically by collections.sort and arrays.sort. Objects that implement this can be used as keys in a sorted map or elements in a sorted set. Natural ordering. It is recommended that natural ordering be consistent with the dot equals. Core classes implement comparable, have natural ordering consistent with equals. Yeah. So, within comparable, every class which implements the comparable interface must have a method called compareTo. And compareTo takes in another object of the same class and returns one of three possible things. It returns either a negative number, a 0, or a positive number, based on whether the first object that you're running it off of is less than, equal to, or greater than the object you're passing in as a parameter. This is how, so for string, instance methods, char at, code points, compare to. I said compare to. So, Java string has a compare to method. Compares two strings lexicographically. Okay, what does lexicographically mean? It means dictionary order. So, compare to takes two strings and it tells you which one would go first and which one would go second if they were written in the dictionary together. So, let's give an example of using compare to. Let's comment out this. And so let's make. Okay, so I'm gonna do a little bit of stuff here. I'm gonna create an array of strings, and then I'm going to sort the array of strings. And I'm going to do this relying on the fact that string is comparable. And of course, I can't simply say arrays.store without doing import Java util arrays. Okay, so what you've just seen is also a quick look into my workflow of write some code, realize that there's some specific thing about the language that I don't remember, open a new Google tab, quickly look it up, take the little bit of information I was looking for, namely, does sort return something, or does sort simply happen in place? And because sort is a void return type, I realize sort just works in place. Go back over, get a stupid error message, go back to the documentation pages, realize that the Java arrays class is within util rather than within lang, realizing that I need to import arrays in order to be able to use it. And then I can do the thing that I wanted to do. So, taking the original string, the quick brown fox jumped over the lazy dog, which we're going to actually just jump that down to lowercase because uppercase and lowercase don't sort quite the same way. Uppercase sorts earlier than lowercase. So if you have uppercase letters in a string that you're and a couple strings you're trying to sort based on each other, the uppercase letters will get pushed forward. So, take a string, quick brown fox jumped over the lazy dog, split it up into an array using a space as the split point, and if you're curious about the string.split method, hey, look! String.split. We're on the documentation pages for talking about strings, and there's a definition of the split method. Then arrays.sort. .sort object A. Arrays.sort object A. Because there isn't an explicit version of arrays.sort that works on strings. It just uses the object version of it, where source the array of objects into ascending order. All elements in the array must implement comparable. And at this point, I just lost my train of thought. What is comparator and comparable? Okay, so comparable dictates that objects of this class must be able to be compared to each other for purposes of greater than, less than, or equal to ordering primarily for purposes of sorting. So comparator is another class that exists. Oh, great, it's a functional interface. Okay, so a comparator is... Okay, a comparator is it's an object that lets you do comparisons between objects of a specific type. If you're in a circumstance where you honestly, I really, really don't want to try to define what comparator is right now. Just know that it's an object that does the compare to thing. I really don't want to try to define it because functional interface is a nightmare to me, and I really don't think functional interface should exist in the Java language, but it exists, and yeah. And it's well above the complexity level of what we're trying to work with here, because we're talking Java, we're talking an object-oriented language, we're not talking functional programming here. You want to talk functional programming, go over what's a good functional language we have around here. Actually, I don't know what functional programming language. Oh yeah, technically JavaScript is functional programming language. Except I don't know if I don't know if AA Web Dev will ever talk about what functional programming is, because he's pretty focused on front end stuff. Other than java.lang, are there any things that are imported by default? I don't think... Are there any objects, any packages other than java.lang imported by default? As far as I know, no. So anything that isn't within java.lang you will need to import yourself if you want to use it in your program. I'm suddenly realizing that this lecture is going to be a bit of a nightmare for me to turn into a notes file. Oh well, we'll cross that bridge later. Okay, package, classes, methods come into play with packages. Package is the folder that holds all relevant classes. Class is a group of functions and data and a blueprint for new objects. And method is a function of a class, yeah. Other than Java lang, other package imported by default, no. Comparable allows you to check and see if an object is greater than, less than, or equal to another object. Thing about comparable, honestly, I can personally never keep track of which way it does the comparison, whether it takes first thing is greater than second thing or first thing is less than second thing. So like anytime I'm ever playing with comparable, I always just like quickly test it once for myself to figure out which way it is and then move on and actually use it. As for what a comparable thing would look like. So when I was doing the arrays.sort uses comparable, but give me a minute to invent an example for using comparable just on its own. Okay, so let's look at this. So I have a string first of a bunch of capital letters, and a string second of a bunch of lowercase letters. I'm going to print out the results of comparing the two strings to each other via the compare2 method, and then demonstrate a use of the value returned by compare2. Okay, so first .compare2 second states that lowercase letters would come earlier in the dictionary than uppercase letters. That lowercase letters has the string lowercase letters has a lower compared value than the string capital letters. Now it so happened that the compare2 method returned the value -41. You can't know exactly what sort of value compare2 is going to return. All you can know is that the value will either be less than 0, equal to 0, or greater than 0. and so you need to work with it based on greater than 0, less than 0, or equal to 0. And because the only three possibilities are greater than, less than, or equal to 0, because the only possibilities are greater than, less than, or equal to 0, and because you don't know what exactly the values are going to be, if you are working with compare2 manually, you pretty much need to do it as a if, else, three-case thing. Okay. Is that a good enough working explanation of what comparable is and how comparable works? Thumbs up. Okay. We are now at 1928, which means this lecture has been going on for just about an hour and 20 minutes, which is, well, just short of an hour and 30 minutes, which is how long we were supposed to run this lecture for. So, I got through the things that I wanted to talk about today with method signatures, static keyword, Java documentation pages, a couple of questions about some things that were seen on the Java documentation pages, opened a whole bunch of Chrome tabs, panicked over functional interface, and then talked about comparable. Okay, I think that's a lecture for the day. Alright, so that's a lecture for the day. We'll be having another lecture next week. I intend to not be delivering next week's lecture. I intend to pass it off to someone else so they can talk about something else. I don't know exactly what next week's topic is going to be. We'll discuss that and we'll announce it within the next few days. And I think that's everything for now.